This is Pallavi Govekar from the Bureau of Meteorology. I would like to thank my Bureau and University operating colleagues listed here for their input to this presentation. I am going to talk about new Himawari 9 sea surface temperature products that we developed with collaboration of University operating at the Bureau and newly developed thermal stress monitoring tools for the Australian coast with use of composite geopolar multi-sensor level 3 SST products made with compositing Himawari data with data from polar orbiters. In recent years, we collaborated with University of Reading and modified method that they developed for ESA Climate Change Initiative SST products. This method retrieves SST with radiative transfer model and Bayesian approach used for cloud masking. Recently, we updated this method to use CCI version 3 code. We redefined lookup tables and used RT2 13.2 and updated code to better tune Bureau's NWP outputs. The upper panels here show improvements in data coverage for 10-minute instance. So we get about 40% extra data. We also updated our previous bias model. So the lower panel here showing difference between satellite and in situ SSTs over the domain for Himawari 8. The left hand shows performance of bias model for day and night and before and after bias correction. The right hand side shows results from new bias model. We see more white spaces indicating closer to zero biases. With the new bias model better represents latitudinal and time changes. The previous cold bias is significantly reduced, particularly in the tropics and the region south of Australia. Data from SNPP, NOVA 20, METOP B, METOP C, and Himawari are composited to construct the new geopolar multisensor L3S SST product. So the left hand side here shows SST data coverage from our operational multisensor, which is composition of NOVA 18, METOP B, NPP, and NOVA 20. And right hand side panel shows data coverage from new geopolar multisensor L3S. We get at least 20% more data coverage by adding Himawari data to composite SST product. The Bureau's RIP-Temp next generation, so we will call RIP-Temp hereafter. It has provided heat stress monitoring tools for the Great Barrier Reef region for 2012 to 2024. So this month earlier, this system was decommissioned. And these tools have been extensively used by marine managers, government agencies, researchers for managing the GBR marine park. The metrics like SST anomaly, degree heating days, degree heating day counts, mean positive summer anomaly were provided for 1 day and 14-day SST products. Similar tools for all Australian coasts are essential for understanding extreme events such as marine heat waves and their potential impacts on marine systems. So for our new metrics, we use bias corrected SST at 0.2 meter depth, calculated using night only geopolar multisensor L3S product with quality greater than 2. The SST Atlas of Australian Regional Seas, that is STARS Climatology, which was constructed using 25 years of AVHRR L3S data for the 92 to 2016 period, was used as a baseline climatology for this work. And then we also use the mosaic technique. So because we are using infrared channels data, where there is a cloud, there is no data. So to fill up those gaps, we for each pixel that has missing data with the most we filled it with the most recent daily SST available for the prior 13 days of the current date for that pixel was used to fill in the data gaps. The new matrix will cover the whole of the Australian coastal region, so that is from 100 east to 165 east and 7 south to 40 east south. SST anomaly is calculated by subtracting the corresponding daily star climatology from the SST at 0.2 meter depth. Degree heating day is calculated progressively by accumulating positive SST anomaly values throughout the summer days. Degree heating day count indicates the number of days that contributed to the degree heating day values reported for the pixel. And mean positive summer anomaly is the average severity of thermal stress calculated by dividing the DHT with the DHT count pixel by pixel. And figure here is showing metrics for mosaic SST product. So for the sanity check, we are comparing our metrics with RipTemp. Please note there are many differences between these two methods. The SST product used to define metrics are different. Also, climatology used are totally different. We are using STAR's daily climatology, which was constructed using 92 to 2016 SST data, while RipTemp used IMAS climatology, which was constructed using data from 2003 to 2012 period. So the upper panel in the figure shows mosaic SST and mosaic age for new method. Lower panel shows same for the RipTemp. So the mosaic generated with the use of new method shows fewer dates for mosaic age, indicating that it contains more contemporary data, better representing data on the reported date. So now here this figure is showing difference between two climatologies used by two methods, and that is for summer months December, January, February and March. We did not find any pattern in this difference. The difference between the two climatologies is within plus or minus 0.5 degree across the Great Barrier Reef region. The DHT from new method is shown in left panels, and from RipTemp is shown in right panels for 2015-16 to 21-22 summer seasons. So summer seasons start from December the early year and then ends in March of the year. So with the use of high resolution geopolar multisensor L3S, we can see new thermal stress metrics across the GBR are defined at a very high resolution. 2015-16, we can see that the new system indicates higher DHT values in the northern and central GBR, whereas in 1920 it shows elevated degree heating day values in the central and southern GBR. So, and rightmost hand panels are taken from Hughes et al. 21 study, which showed severity of coral bleaching in the GBR region. So the red color denotes the severe bleaching. The most severe coral bleaching primarily occurred in the northern and central GBR during 2015 and 16, while in 2019-20 the central and southern GBR experienced the most severe coral bleaching. These reports aligns with our metrics, and the new method is more aligned with this bleaching data. Over the coming year, we will be producing real-time IMOS Himawari 9 L2P, L3C and Geopolar Multisensor L3S SST products, and we will replace back to December 22. New developed thermal stress metrics are at a very high spatial resolution, exhibiting greater feature resolution. And marine heatwave monitoring tools like marine heatwave intensity and category will be defined following definition of Hopte et al. 2018 and will be added to this product suite. These products will be made available in NetCDF format to IMAS Ocean Current and IMAS Ocean Current for display and to AODN. And here are the references that were used for the study. On that note, I will stop here. Thanks for your attention and time.